A very good morning, dear students. Today we will discuss the topic glycolysis. It is an important topic, comes under the metabolism of carbohydrates, and glycolysis is otherwise known as Embden-Meyerhof-Parnas pathway or EMP pathway, and this name was given in honor of scientists who has contributed towards the knowledge of glycolysis. And coming to glycolysis can be defined as a sequence of reactions which converts glucose to pyruvate or lactate with the production of ATPs. Conversion of glucose to pyruvate or lactate with the production of ATPs. So glycolysis can be defined as a sequence of reactions which converts glucose to pyruvate or lactate with the production of ATPs. Today we will discuss some important features of glycolysis, then various reactions involved in glycolysis, then energetics, then regulation of glycolysis. Coming to the features of glycolysis, first one is that it occurs in all cells of our body. It occurs in all cells of our body. The glycolytic enzymes are present in cytoplasm of our cell. The glycolytic enzymes are present in cytoplasm of the cell. Then second one is that glycolysis occurs both in aerobic and anaerobic way. Aerobic and anaerobic way. If it happens in anaerobic way, lactate is the end product. If it happens aerobically, pyruvate is the end product. Pyruvate is the end product for aerobic glycolysis, and lactate is the end product for anaerobic glycolysis. And third one is that glycolysis provides energy for those cells which lacks mitochondria. For example, matured RBC, cornea and lens. Then during vigorous exercise, glycolysis provides energy for muscles by acting anaerobically. During vigorous exercise. Glycolysis provides energy to muscles by acting anaerobically. And then the activity of glycolysis is low in cardiac muscles. Then the intermediates of glycolysis are involved in the synthesis of non-essential amino acids and fat. The intermediates of glycolysis are involved in synthesis of non-essential amino acids and fat. So intermediates of glycolysis are involved in the synthesis of non-essential amino acids and fat. Then the reversal of glycolytic steps. The reversal of glycolytic steps cause the production of glucose. It is known as gluconeogenesis, which we will discuss later. So I will discuss once again. The important features of glycolysis are: it occurs in all cells of our body. The glycolytic enzymes are present in cytoplasm of the cell. Glycolysis occurs in all cells of our body. The glycolytic enzymes are present in cytoplasm of our cell. Then it occurs both aerobic and anaerobic way. If it occurs in anaerobic way, lactate is the end product. If it occurs aerobic way, pyruvate is the end product. Glycolysis provides energy for those cells which lacks mitochondria. For example, matured RBC, cornea and lens. Then during vigorous exercise, glycolysis provides energy for muscles by acting anaerobically. Then the activity of glycolysis is low in cardiac muscles. Then several intermediates of glycolysis are involved in the synthesis of non-essential amino acids and fat. Then the reversal of glycolytic steps cause the production of glucose. It is otherwise known as gluconeogenesis, and we will discuss it later. See, coming to the steps involved or various reactions of glycolysis. First is glucose. The glycolysis is a conversion of glucose to pyruvate or lactate. So glucose converts into glucose 6-phosphate. I'm writing only P for phosphate. Glucose 6-phosphate. Glucose 6-phosphate converts into fructose 6-phosphate. And this fructose 6-phosphate converts into fructose 1,6-bis-phosphate. Fructose 1,6-bis-phosphate, and then again it splits into two. Fructose 1,6-bis-phosphate splits into two by one is dihydroxy acetone phosphate, and then other one is glyceraldehyde 3-phosphate. These two are isomerized. Then glyceraldehyde 3-phosphate is converted into 1,3-bis-phosphoglycerate. 1,3-bis-phosphoglycerate is converted into 3-phosphoglycerate. Then 3-phosphoglycerate is converted into 2-phosphoglycerate. Phosphoglycerate is converted into phosphoenol pyruvate. Phosphoenol pyruvate is converted into pyruvate. This is the end of aerobic glycolysis. So first, the conversion of glucose to glucose 6-phosphate. It is catalyzed by the enzyme glucokinase or enzyme hexokinase. These are isoenzymes, glucokinase or hexokinase. Glucokinase is otherwise known as hexokinase 4. See, this step involved ATP. This step requires ATP. So, with the help of ATP and magnesium ions, glucose is converted into glucose 6-phosphate, which is catalyzed by the enzyme glucokinase or hexokinase. Then, important point to remember is that this step is an irreversible step. Conversion of glucose to glucose 6-phosphate is an irreversible step. Then, second step is isomerization. Isomerization of glucose 6-phosphate to fructose 6-phosphate. The enzyme catalyzing this reaction is phosphohexose isomerase. The enzyme phosphohexose isomerase. This is an irreversible step. The enzyme phosphohexose isomerizes glucose to fructose 6-phosphate. Glucose to fructose 6-phosphate. This is an reversible reaction. Then conversion of fructose to fructose 1,6-phosphate, bis-phosphate. That is by the enzyme phosphofructokinase. Phosphocrinase, and this step is also an irreversible step. See, we have to remember first step, conversion of glucose to glucose 6-phosphate and fructose 6-phosphate to fructose 1,6-bisphosphate. These two steps are irreversible, and the conversion of fructose 6-phosphate to fructose 1,6-phosphate is by the enzyme phosphofructokinase, and this step also involves an ATP. Fructose 6-phosphate is converted to fructose 1,6-bisphosphate by the enzyme phosphofructokinase. This step also involves ATP. ATP converts into ADP. Then the next step is the splitting phase. Fructose 6-carbon fructose 1,6-bisphosphate is splitted into 3 carbon compounds. One is dihydroxyacetone phosphate and other one is glyceraldehyde 3-phosphate by the enzyme aldolase. With the help of enzyme aldolase, fructose 1,6-bisphosphate is splitted into 3 carbon compounds, dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. And these two, dihydroxyacetone phosphate and glyceraldehyde 3-phosphate, are immediately interchanged with the help of enzyme phosphotriose isomerase. With the help of enzyme phosphotriose isomerase, dihydroxyacetone phosphate and glyceraldehyde 3-phosphate are interchanged. So we will get 2 molecules of glyceraldehyde 3-phosphate. Then with the help of enzyme glyceraldehyde 3-phosphate dehydrogenase, glyceraldehyde 3-phosphate dehydrogenase. With the help of glyceraldehyde 3-phosphate dehydrogenase enzyme, glyceraldehyde 3-phosphate is converted into a high energy molecule, that is 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate. This step produces an NADH. High energy compound. NADH. This NADH enters into electron transport chain and produces 2.5 ATPs. NADH enters into electron transport chain and produces 2.5 ATPs. Here 2 molecules of glyceraldehyde 3-phosphates are there. So 2.5 into 2, totally 5 ATPs are produced. Then 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate by the enzyme phosphoglycerate kinase. Phosphoglycerate kinase enzyme converts 1,3-bisphosphoglycerate to 3-phosphoglycerate. And 3-phosphoglycerate is isomerized to 2-phosphoglycerate by the enzyme phosphoglycerate mutase. Phosphoglycerate mutase converts 3-phosphoglycerate to 2-phosphoglycerate. And then 2-phosphoglycerate is converted into phosphoenol pyruvate by the enzyme enolase. The enzyme enolase converts 2-phosphoglycerate to phosphoenol pyruvate. And the enzyme pyruvate kinase converts phosphoenol pyruvate to pyruvate. And we have to remember the conversion of phosphoenol pyruvate to pyruvate is also an irreversible step. So there are 3 irreversible steps in glycolytic pathway. They are: first one, conversion of glucose to glucose 6-phosphate, then fructose 1,6-phosphate to fructose 1,6-bisphosphate, then phosphoenol pyruvate to pyruvate. These 3 steps are irreversible steps. And then here, conversion of 1,3-bisphosphoglycerate to 3-phosphoglycerate involves substrate level phosphorylation. And it does not involve electron transport chain. that is on ADP is converted into ATP. Substrate level phosphorylation. Here also conversion of phosphoenol pyruvate to pyruvate also involves a substrate level phosphorylation, that is ADP is converted into ATP. So this is a aerobic glycolysis, and the end product of aerobic glycolysis is pyruvate. So I will repeat. Conversion of glucose to glucose 6-phosphate. This is an irreversible step. Catalyzed by the enzyme glucokinase or hexokinase, and it utilizes a molecule of ATP for the conversion. Then glucose 6-phosphate is converted into fructose 6-phosphate by the enzyme phosphohexose isomerase. Then fructose 6-phosphate is converted into fructose 1,6-bisphosphate with the help of enzyme phosphofructokinase, and it also utilizes one ATP molecule. And we have to remember conversion of fructose 6-phosphate to fructose 1,6-bisphosphate is also an irreversible step. Then here this is a splitting phase. Fructose 1,6-bisphosphate is split into two 3-carbon compounds, which are dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. The enzyme catalyzing this reaction is aldolase. Then dihydroxyacetone phosphate and glyceraldehyde 3-phosphates are rapidly interchanged by the enzyme phosphotriose isomerase. So we will get two molecules of glyceraldehyde 3-phosphate. Then with the help of enzyme glyceraldehyde 3-phosphate dehydrogenase, glyceraldehyde 3-phosphate is converted into two molecules of 1,3-bisphosphoglycerate. Here the high energy compounds NADH are produced. Two NADH are produced. So by entering into electron transport chain, it produces 5 ATPs. Then 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate by the enzyme phosphoglycerate kinase. Here substrate level phosphorylation occurs, and one ADP is converted into ATP. Then 3-phosphoglycerate is converted into 2-phosphoglycerate by the enzyme phosphoglycerate mutase. Then by the enzyme enolase, phosphoenol pyruvate is formed from 2-phosphoglycerate. Then next, pyruvate kinase catalyzes the reaction of or conversion of phosphoenol pyruvate to pyruvate. Here also one substrate level phosphorylation occurs. So ATPs are produced. So we'll see the energetics of aerobic glycolysis. Here two NADHs are produced. So 2.5 into 2, total 5 ATPs. 5 ATPs for the conversion of glyceraldehyde to 1,3-bisphosphoglycerate. 5 ATPs are produced. Then substrate level phosphorylation. Two molecules of 1,3-bisphosphoglycerate converts into two molecules of 1,3-phosphoglycerate. So 2 ATPs are produced. Then for substrate level phosphorylation of phosphoenol pyruvate to pyruvate, 2 ATPs were produced. Total 9 ATPs. And here 2 ATPs were utilized in the conversion of glucose to glucose 6-phosphate, and for the conversion of glucose 6-phosphate to fructose 1,6-phosphate. So 2 ATPs were utilized. So final energetics or production of ATPs are 7 ATPs. 7 ATPs are produced from aerobic glycolysis. 7 ATPs were produced from aerobic glycolysis. In anaerobic glycolysis, this pyruvate is converted into lactate. Pyruvate is converted into lactate in anaerobic glycolysis by the enzyme lactate dehydrogenase. It utilizes NADH. It utilizes NADH to NAD. So 2 molecules of pyruvates are formed. So 2 molecules of lactates are formed. So here 2 molecules of NADH is utilized. So for energetics of anaerobic glycolysis, 2 into 2.5, 5 ATPs were utilized for the conversion of pyruvate to lactate, minus 5 ATPs, so 2 ATP. So 2 ATPs were produced for anaerobic glycolysis. So this is all about glycolysis and its energetics. Coming to the regulation, we have discussed that there are 3 irreversible steps in glycolysis, that are glucose to glucose 6-phosphate. Conversion of glucose to glucose 6-phosphate by the enzyme glucokinase or hexokinase. Then fructose 6-phosphate to fructose 1,6-bisphosphate by the enzyme phosphofructokinase. Then phosphoenol pyruvate to pyruvate by the enzyme pyruvate kinase. These three are the irreversible steps involved in glycolysis. See, first one, glucokinase, and first regulatory enzyme is glucokinase and hexokinase. This hexokinase enzyme is inhibited by glucose 6-phosphate. Hexokinase enzyme is inhibited by glucose 6-phosphate. That is the product inhibition. While glucokinase is not inhibited by glucose 6-phosphate. So we have to remember glucose 6-phosphate inhibits only hexokinase, not glucokinase. See, glucokinase is an inducible enzyme. Inducible enzyme means it produces only when it requires. Glucokinase acts only when the concentration of glucose is high. So it produces when the glucose concentration is very high. So it is an inducible enzyme. Hexokinase is a non-inducible enzyme. Then coming to the second regulatory enzyme, phosphofructokinase. It is the rate limiting and committed step for regulation. See, phosphofructokinase is the rate limiting and committed steps for regulating glycolysis. Phosphofructokinase. Phosphofructokinase is inhibited by, allosterically inhibited by ATP, then hydrogen ion concentration and citrate. Allosterically inhibition. Then phosphofructokinase is allosterically activated by fructose 2,6-bisphosphate. Fructose 2,6-bisphosphate. It is allosterically activated by fructose 2,6-bisphosphate, AMP and ADP, and inorganic phosphate. Phosphofructokinase is the rate limiting and committed step for regulating glycolysis. It allosterically activated by fructose 2,6-bisphosphate, AMP, ADP and inorganic phosphate, and it allosterically inhibited by ATP, low pH and citrate ions. Then another step for regulatory enzyme is pyruvate kinase. Pyruvate kinase is inhibited by ATP. Pyruvate kinase is inhibited by ATP and activated by fructose 1,6-bisphosphate. Activated by fructose 1,6-bisphosphate. So finally, the difference between hexokinase and glucokinase. Hexokinase and glucokinase. The main difference is that hexokinase acts on all hexoses, but glucokinase acts only on glucose. Hexokinase acts on all hexoses, but glucokinase acts only on glucose. Then hexokinase has high affinity for glucose. Hexokinase is having high affinity for glucose, but glucokinase is having low affinity. That is, it is having a high Km value. Hexokinase is having a low Km value, that's why high affinity. Then glucokinase will not be inhibited by glucose 6-phosphate, but hexokinase is inhibited by glucose 6-phosphate. Glucose 6-phosphate is inhibited by glucose 6-phosphate. Sorry, hexokinase is inhibited by glucose 6-phosphate, but glucokinase is not inhibited by glucose 6-phosphate. Then it is non-inducible enzyme. Non-inducible. Glucokinase is inducible enzyme. It produces only when it requires. It acts only when the concentration in high concentrations of glucose. It acts when the glucose concentration in our blood is high. That is only after a high fat diet, above 100 milligram per dl. So at high concentration of glucose only glucokinase is active. But hexokinase is active in low concentrations of glucose. It is active in low concentration. So the difference between hexokinase and glucokinase are hexokinase acts on all hexoses, but glucokinase acts only in glucose. Then hexokinase is having high affinity towards glucose, so that is, it is having low Km value, but glucokinase is having low affinity towards glucose, that is, it is having a high Km value. Hexokinase is inhibited by glucose 6-phosphate, but glucokinase is not inhibited by glucose 6-phosphate. Hexokinase is non-inducible enzyme, but glucokinase is an inducible enzyme. Hexokinase acts at low concentrations of glucose, but glucokinase acts only at high concentrations of glucose, that is above 100 milligram per dl. And another one point is that while taking blood for glucose estimation, we will select fluoride tubes. Fluoride tubes because fluoride ions inhibit enolase enzyme. Fluoride ions inhibit enolase enzyme. Inhibit enolase enzyme, and thus the glycolysis is stopped, so we will get a correct result. See, we will take blood in fluoride ions during glucose estimation because fluoride ions inhibit enolase enzyme involved in glycolytic pathway, which converts 2-phosphoglycerate to phosphoenol pyruvate. So that's all about glycolysis. Thank you.